So in grade 10, we started with forces calculations, but we only did the basics of it, and I don't think you guys can really remember much about it. So I'm just going to recap and actually just start from the beginning to explain this to you guys. Okay, so when we look at forces, I want you to look at the Cartesian plane first. So we know that this is our Cartesian plane. So you have your x-axis and your y-axis. And this is my horizontal plane and my vertical plane. Now inside all of these blocks you're going to have, or even on these lines, you're going to have forces that's going to be represented. Okay. Now the one thing that I want you to always look at is that all of the forces always have to point outwards. The arrows. Okay. So that's one thing that's going to be there. Then I want us to look at the degrees of each block. So we know that the x starts at 0 degrees. Then from 0 to the first line, it's 90 degrees. And this is also my first quadrant then. Anything after 90, so let's say it's 90,01 or 91, up until 180 degrees, the second line, is my second quadrant. And then from anything after 180 up until the next line is 270 degrees, and this is my third quadrant. And then anything after 270 degrees up until 360 degrees is my fourth quadrant. Okay, so this is what we're going to look at, what divides our 4 blocks for us. Then you get a rule that they call the cast rule. You know, when you do fishing, you cast the line in. So the cast rule looks like this when I draw it in. And what this actually means is that in the fourth quadrant, only cos is positive. In the first one, all of them, sin, cos, and tan, is positive. Here only sin is positive, and here only tan is positive. Okay, so that is important for one of the methods that you use to calculate the resultant force. Now the whole purpose of doing all of this is to get a resultant force. So what a resultant force is, if let's say you have a box that you want to move, but it's a very, very heavy box. Now usually you'll need 3 guys to be able to pull or pick this box up. Or you can look at it as in the industry as 3 machines that have to do the work to pick up this one thing. Now you don't want to waste 3 people or 3 machines to do the work of what one person or one machine can do. So you want something, a force, that is just as strong as all of the other forces in the system together. And this is called my resultant force. Okay. And this is why we are doing all of this, because you're going to get a diagram with a lot of forces in it, but we at the end just want the resultant force. We want to work out what force do we need to be able to do the work of all of the other forces together. Okay. But there's different components to the resultant force, because first of all we need to know what the size of the resultant force is. Remember, force is measured in newtons. Then we need to know in the block now, okay, what angle do we need to pull it at. So we need the angle in degrees. And then also, yes, we know what angle it's going to be at, but is it going to be 50 degrees north west or southeast, or what direction is it going to be in? So remember, you get your different directions as well: north, south, east, and west. So we want to also know what direction do we need to pull this force at. Okay, so we need all 3 of those things in the end to get the actual resultant force that's going to do the work of all those forces together. But then you also get something that's called your equilibrant force. So let's say this is my diagram and you got your resultant force over there. And it was 10 newtons, and the angle that you had to pull it at was 45 degrees, and obviously it's located in the northeast block. Now, you get a force that actually works against this force, that will keep it standing still, and that's called your equilibrant force. So that means my equilibrant force is going to be exactly the same size and the same angle, but just in the opposite direction, like it's pulling it. Okay, so still 45 degrees, but now it's in the southwest block. And that is my equilibrant force. So the whole point of that is to work against your resultant for it to be able to stand still or be at a 0 point. So it can't be larger or smaller, otherwise it's not going to be able to pull against it. It has to be the same size. Okay, so we're going to, if they ask you ever to calculate the equilibrant force, you still have to work out all of the steps to get the resultant force, and then all that you do is you just write the opposite direction. But I'll show you when we've done the example. Okay, so there's 7 steps that I always want you to follow when we're doing this work. Alright, and I'm going to go through them with you now and then show you in the example how you use them. So the first step is to check that all of the arrows are pointing in the same direction. And when I talk about arrows, I mean actually the forces. So if you look at this diagram here, this is my X and my Y, so my 0 degrees over there. You have 3 forces in this diagram. Force number 1 is pointing outwards, so that's fine. Force number 2 is outwards, which is also fine. But force number 3 is going in instead of out. And that's where my problem lies. It has to go out in the same direction as all the other forces. So all that I'm going to do is, it's already on its way over there. So I'm just going to extend it. So let's say it was 3 newtons. It still stays 3 newtons. But instead of it being in my tan block, it's going to be in my all block now. Instead of my third quadrant, it's going to be in the first quadrant now. And if this was 30 degrees, then this angle over here is also going to be 30 degrees, one of your math rules now. But it's not here anymore, it's now in this block, because now all of them are pointing outwards. It doesn't exist there anymore, it's just over there. You're still your 3 forces now. Okay, so that's what I mean by checking that all of the arrows are in the same direction. Then step number 2, check that all of the forces has an angle with my 0 degree line. So all of these forces, sorry, that is my dog barking. All of my forces have to have an angle with my 0 degrees. So there's my 0 degrees. So force number 1 is on the 0 degree line. So then we know that force number 1's angle is obviously 0 degrees. This is the one that I'm going to work with. Then I made this number 3 because it's the one that got extended. Number 3, the angle from him up until 0 is then 30 degrees. And then you want to go check force number 2. Okay, they didn't give you anything now, but just let's say, for example, they gave you this angle as 45. Then 45 plus 90 will give you 135. And that will give you then the angle to the 0 degree line. Okay, and these are the angles that we're going to work with. Okay, so that is to check, to do step number 2. Step number 3, they're going to ask you to calculate the horizontal components by using cos. So what they mean about by that is, remember, we want to calculate the resultant force. So to get resultant force, we are going to use Pythagoras. Okay, so R stands for resultant. My X is actually, remember, it's the X line is my horizontal line, so this is my horizontal components, and Y is vertical, so it's going to be my vertical components. But I'll show you how we're going to do it. But to get the horizontal components, in other words, x, I'm going to use cos. Remember, you use sin, cos, and tan. And an easy way to remember this is, remember in Afrikaans they talk about kos is food that you eat. So let's say it's a ladies' Sunday afternoon and you had a lot of kos to eat then. What do you usually want to go and do? You want to go lie down and sleep. Okay, but we're not vampires. We don't sleep vertically. We sleep horizontally. Okay, so as you baie kos geëet het, you ate a lot of food, then you want to go down, lay down horizontally a little bit. Okay, so those two always go together. Then to get your vertical components, so my y, I have to use sin. Okay, and an easy way to remember this is when you're naughty and you do a lot of sin, you're going to go straight down to hell. Okay, so a lot of sin, straight down to hell. So those two always go together. So that's so easy, just a way to remember those things. Okay, then step number 5, they say you have to calculate the resultant force. So in other words, we want to calculate that by using Pythagoras. Then step number 6, calculate the angle of the resultant force by using tan theta equals y over x. Okay, so that means that we're going to calculate there, the angle that it has to be at, the angle. And then step number 7, draw a freehand diagram to find the direction and write your final answer down. So we want to get the direction that it's going to be, so north, east, south or west. And by that we have to draw a little freehand diagram that I will show to you. And then we're just going to write down the final answer, sorry. Okay, so let's look at example 1. Now, the first thing before we even start with our steps, I want you to just go and number these for you to make it a little bit easier. So let's make the 60 newtons number 1. Then the 80 newtons number 2, and the 40 newtons number 3 in the diagram. Okay, so now we're going to follow our steps to do this. Now they're always going to give it to you like this. Now obviously the 60 newtons is, you can see, is your horizontal line, so that means it's where the 0 degrees is going to start. And you can finish your diagram by just filling in little lines like that, and because that is at the 90, this is going to be my y, just so you can see the Cartesian plane for yourself and just make it a little bit easier. So step number 1, they said, check that all of the arrows are pointing in the same direction. Okay, force number 1 is out, so it's fine. Force number 2 is going out, so that's fine. But force number 3 is going in. So what do I have to do? As it is going that way, I'll just extend it again that way. But now the 40 newtons is not in tan anymore. It's now in the all block. Okay, so now force number 3 is lying over there. But now I need to go figure out, okay, so let's just do that. We did step number 1, check that all the arrows are in the same direction. Okay. Step number 2, check that all of the forces has an angle with my 0 degree line. So force number 1 is on the horizontal, on the 0 degree line. So its angle with the 0 degree is 0. It's on it. Then number 2, from there to the 0 degree line is, if they draw this little block, it means it's 90 degrees. And then force number 3, we have to go and figure out now. So we knew when it was on this side, that from there up until the purple line, so up until my 90 degrees, it was 135. Now, another rule that we know is that when you look at this as a straight line, all of the angles on a straight line is equal to 180 degrees. Okay, so I know that this is 180 degrees, and I just need this little part over there. So I'm just going to say, you can either look at that, or you can go say, we know that this block over there is 90 degrees. So if I take away the 90 from the 135, I'm going to have this block over there. So 135 minus the 90 is going to give me the block that's left over there. That's 45 degrees. Okay, so we know that this is 45 degrees, and then that means that the angle that's exactly adjacent to it, or opposite it, it's also going to be 45 degrees. And that is exactly the angle that I need to get to my 0 degrees. So that means that the force number 3's angle to the 0 degree is 45 degrees. Okay. Then they said, step number 3, calculate the horizontal components. So what I'm going to demonstrate for you guys is how you do step number 3 and 4 in one movement. Okay, actually as one step. So what you do is you draw a little table for me, and you divide it into 2. On the left hand side you write horizontal components, which is actually the x. And on the right hand side you write vertical components, which is my y. Okay. Now remember I said when you eat a lot of costs, so food, you want to go lay down horizontally. So that means we're going to have to use costs on this side. And if you do a lot of sin, you're going to go straight down to hell. So we're going to use sin on this side. Okay, but how many forces do we have? We have 1, 2, and 3. So in pencil, you can somewhere number them like this on each side. So you remember to do 3 horizontals and 3 verticals, and you don't make a mistake. Okay, so that means I'm going to have to write cos 3 times, and I'm going to have to write sin 3 times. So whenever you do this, I always want you to write the size of the force. Remember, F stands for force, on the front, and the size of the angle at the back, like that. So that will be those angles, or in our case, those angles. Okay, so let's look at force number 1. How big is it? It's a 60 newtons. So on both sides I'm going to write 60. And what is the angle that it made with the horizontal line? The 0 is 0 degrees. Force number 2 is 80. And the angle that it made is 90 degrees. And then force number 3 is the 40 newtons. And the angle that it made over there is 45 degrees. Okay, and then you just draw a little line there, because I'll show you how we're going to add this up. So let's start with our cos. So the first one, you say 60 cos 0, and you close the bracket, equals to 60. And remember, there's no minus in front of it, so it means it's a positive answer. The second one is 80 cos 90, close the bracket, gives me 0. And the last one, 40 cos 45, close the bracket, is 28,28. And all of this is newtons, because we're working with forces, name. Okay, let's look at the vertical components. 60 sin 0 gives me 0. 80 sin 90 is 80. and 40 sin 45 is also 28,28. Okay, so now I have all of these individual x's and y's, but I want a total answer to be able to do my Pythagoras, eh? So I'm going to count up what is my total x answer and what is my total y answer over there. So 60 plus 0 plus 28,28 gives me 88,28 newtons. You have to write newtons, otherwise you don't get the marks. And on this side, 0 plus 80 plus 28,28, and that gives me 108,28 newtons. Okay, so now I know what my total x and my total y is. So we have step number 4 and step number 3 and 4. Step number 5 is to calculate the resultant force by using Pythagoras. So now you're going to write R equals x squared plus y squared. So R stands for the resultant. My x we just calculated as 88,28 squared. Always put the 2 on the outside, plus 108,28 squared. Okay, so I want the r to be alone. So how do I get it alone? I have to use a square root. And whatever I do on this side, I have to do on that side. So I square root this whole calculation on that side. You can go do it as you work out these two individually first, and then use the answer and put it under a square root. But don't take away the 2's because you have a square root over it. It's not mathematically correct to do that. Okay, so let's go get the resultant forces answer. Square bracket 88,28, close the bracket, plus bracket 108,28, close the bracket, squared, equals 139,71. The 6 makes the 0 or 1, and it's a force which is in newtons. Okay, so that actually means that we got this part of my resultant that I need, but now I still need the angle and the direction. So step number 6 says, to calculate the angle of resultant force by using tan theta equals y over x. So you can write tan theta equals y over x. Now my y we got as 108,28 over 88,28. So you'll see that sometimes you are going to get an answer that's negative, which is fine. There's nothing wrong with it. But when you do this part of the calculation, don't put the negative in there because it might give you a different answer. Okay, so you always keep it positive when you're doing this. The negative is just going to come in at the next part that we're doing. Okay, so we want theta alone. How do I get tan away? Not dividing it, by saying shift tan, like you guys know by now. 108,28 over 88,28, close the brackets. And that gives me 50,81 degrees, because now it's an angle. Okay, so now we have this part of my resultant force. Now I still need this. So that's the last step. Step number 7, draw a freehand diagram to find the direction. So that's all that you're going to do for me is somewhere on your page, you just go do this little X and Y diagram. Because remember, from our 0 point, anything to the right hand side of X is positive, anything to left is negative. Y, everything up is positive, everything down is negative. Okay, so if I look at these two, my X and Y now, my X answer is a positive. So that means that somewhere over here, if you draw a diagram or a graph, it's going to be 88,28. And the y is somewhere going to be here at the top, 108,28. And then if you connect the two, you'll see that your resultant force is lying in which direction now? North, east, south, west. It's lying in the northeast direction. So in other words, you're going to end off by saying the resultant force equals to 139,71 newtons, 50,81 degrees, and it's northeast. Okay, so if they asked you for the equilibrant force, it will be in the opposite direction, still the same size, so you say equilibrant equals to 139,71 newtons, also 50,81 degrees, but it's southwest. Okay, so go right down the steps for yourself so you can always follow them, and then I'm going to give you some calculations that you have to do on your own.